Hello, I'm Adam Keller. I'm a developer advocate on the container service team here at AWS. I'm really excited to be here talking about container image scanning with Amazon ECR. So let's get right into it. So on the agenda today, we're going to do an overview of Amazon ECR, and then we're going to talk about a general generic container image workflow. From there, we're going to talk about where security scanning fits in, and specifically where image scanning fits into that workflow. And then we'll dive into ECR image scanning. We'll go through some example image findings. We're going to talk about that same container image workflow from earlier, but we're going to add continuous deployment into the mix, and we're going to see how we can fit security in there. Once we're done going through that, we're going to dive into a demo. I have a couple different demos that we're going to go through, and then we'll finish up with how to get started with some information and some links on where to go to get yourself started. And then we'll end with some Q&A. So before we get started and actually dive in, we are making some assumptions. One, that there's a high level understanding of Docker and containers in general, and specifically what a Docker container image is and how to work with container images and so on and so forth. So with that, let's talk about Amazon ECR and just do an overview. Amazon Elastic Container Registry is a fully managed Docker container registry that makes it easy for developers to store, manage, and deploy Docker container images. Amazon ECR is integrated with the AWS ecosystem with services such as AWS Elastic Container Service, Elastic Kubernetes Service, Identity and Access Management, and our Key Management Service. An example of an integration would be with Amazon ECS. By simply pointing the image to the image in ECR, ECS will retrieve the appropriate image on your behalf. Amazon ECR stores its images in Amazon S3, which means it inherits the high availability and durability that you get from Amazon S3. ECR also secures your images by encrypting them at rest using AWS Key Management Service, as well as in transit by using HTTPS. And AWS also integrates with the AWS Container Competency Partners. Lastly, Amazon ECR eliminates the need to operate your own container repository infrastructure by letting AWS handle the undifferentiated heavy lifting. So when you think about managing your own container repository, you have to think about managing a front end, scaling the front end, as well as the storage back end. So that's what we would call the undifferentiated heavy lifting that AWS handles. Now, let's start by talking about a container image workflow. This is a very generic container image workflow, but generally you have a developer that's writing their application code as they're iterating and building on their application. There's a Docker file, and that Docker file defines what software is needed to run the application, as well as it includes the application code itself. And this will provide a reproducible artifact and experience that's going to follow through the entire development and deployment lifecycle. So the developer is iterating locally, they test locally against that Docker file, and they're ready to submit their code to go through the pipeline and get built. So typically there's version control. A pull request is submitted to a Git repository. There's peer review, and once that code gets merged, a pipeline automatically gets triggered that will start to run tests on the code, tests against the Docker image, build that Docker image, and then it's going to push it to a container registry. Now, a container registry or repository can either be self-hosted or a managed service like Amazon Elastic Container Registry, ECR. From here, a container can be run from the Docker image that's stored in ECR. And this could be an orchestrator like ECS or EKS, or it could be a developer who wants to pull that image to run tests locally. Now, assuming they have the proper permissions, they can access those container images. Now, looking at the workflow here, there's one glaring omission, and that's security. So where does security fit into this workflow? So when talking about Docker images and running containers, let's look at this from a defense in depth strategy. So first, there's scanning the images statically. This is static scanning. Static scanning is performed in the environments prior to deployment. So this enables teams to detect vulnerabilities before an image ever makes its way to a live environment. This is where ECR Image Scanning falls, which we'll talk about in a little bit. It scans OS packages in the container images for CVEs without having to set up your own scanning infrastructure or pay for third-party licenses. Next is dynamic scanning. So dynamic scanning is actually scanning your images at runtime. So this is executed in your runtime environments, and it enables you to scan for vulnerabilities when the containers are actually running in their environments. This makes it possible to catch vulnerabilities that may have occurred post-build. So you may have a container that's been running for an extended period of time, that's running off of an image that hasn't been updated for a while. Vulnerabilities can pile up, and that's why you need to scan those images at runtime. In the context of today, we're going to focus on static scanning of images in ECR. Amazon ECR Image Scanning helps in identifying software vulnerabilities in your container images. Amazon ECR uses the Common Vulnerabilities and Exposures Database, otherwise known as CVEs, from the open source CoreOS Claire project and provides you with a list of scan findings. You can review the scan findings for information about the security of the container images that are being deployed. Amazon ECR uses the severity for a CVE from the upstream distribution source if it's available. Otherwise, we use the CVSS score. CVSS is the Common Vulnerability Scoring System, and the CVSS is an open framework for communicating the characteristics and severity of software vulnerabilities. When it comes to enabling scans, there are two ways you can do it. One, you can manually scan container images that are stored in ECR and just scan ad hoc. Or two, you can configure your repositories to scan images when you push them to a repository. So we call that on push. With this data, the scan findings, you can derive actionable insight into your container images. Amazon ECR sends an event to Amazon Event Bridge. This is formerly known as CloudWatch Events, when an image scan is completed. From here, notifications can be sent. You can determine what actions you want to take based on your security policy. Some examples would be you could trigger a notification to send an email to a SecOps team. Or on an event where there's a critical or high vulnerability or multiple critical high vulnerabilities, you could set auto remediation to not allow that image to be deployed to your environments. And this would be like in a CI/CD pipeline, which, little sneak preview, we're actually going to demo that coming up in a little bit. Lastly, image scanning is available at no additional charge. And so with that, what I'd like to do now is look at some example findings from ECR image scanning. And we're going to approach it in two ways right now. First, we're going to look at the console experience and what that looks like. And then two, we're going to look at the command line and see what the data looks like when you query the scan findings from the command line. So this is, I'm drilled down into an ECR repository, and you can see here, it gives me all my images. In this example, I just have one image. It's tagged latest. I have all the information about the image when it was pushed, the size of the image. But to the right here, you'll notice I have the status of the scan, whether it's complete or in progress. And then I have the vulnerabilities. So as you can see here in bright red, we have 2 critical vulnerabilities and 319 others. So obviously I see 2 critical, I see that red triangle, that alerts me that I need to dive in and actually see what vulnerabilities are in this container image. So when we drill down into the findings, we have a nice graphical representation of the critical findings down to the informational and undefined findings. And as you can see, anything that's critical or high has a red or orange color, which indicates visually that these are critical or high vulnerabilities, and they likely will require intervention. So looking at the console here, I can drill down into the vulnerabilities, I can search for them, I can sort by severity, and then I can get into the description of the vulnerability, the package information, so which package has the vulnerability and which version of that package, as well as a link to the upstream CVE. So I can actually go to the upstream source and read more information on the CVE from there. Now, this would be to visually see how you're doing with your image scans and to actually drill down from a visual perspective in the console. But oftentimes we want to do things programmatically. So we can auto remediate, send notifications, or do whatever we deem necessary when events occur. So from the command line, this example is using the AWS CLI, and the results I get are very similar to, or the same as what you see in the console. The difference is it's just in JSON format here. So here you see I have the name of the package, the description of the vulnerability, the URI, the severity, as well as attributes related to the vulnerability. So it gives me the package name as well as the package version. If I want to just see an overall count of all the severities, I can drill down into that response that I get from the CLI, and I can actually see exactly how many high vulnerabilities I have, how many critical vulnerabilities, and so on and so forth. So this is just a example of what you can get from the command line. Now I want to stop and go back and talk again about that container image workflow, but this time I want to put it in the perspective of a CI/CD pipeline. So I want to add some component of continuous delivery. So as we go further, you see we have, first of all, as we talked about earlier, our build goes to version control, we test locally, submit a pull request, that code gets merged, triggers a pipeline, builds the image, pushes to ECR. But now we have additional steps in our pipeline that takes that image and deploys it to our test environment. Then after a series of tests and validations, it progresses to staging and then to production. Well, what happens in this flow if we don't scan container images? Well, for one, we could be running containers that could have critical vulnerabilities that could potentially leave our environment at risk and leave us vulnerable. So with container image scanning, what we can do is we can actually scan on push. So when this build process happens and then pushes that image to ECR, we can wait for the results. And if there's any critical or high vulnerabilities, we can stop the build. Stop that image from getting deployed to our environments. So what have we accomplished by doing this? Well, we ensure that our risk of running vulnerable images is mitigated before those images get deployed. And what we did was we caught those security vulnerabilities statically before they made it to the dynamic runtime environments. So now I want to go into a demo, because I think the most fun here is actually seeing this live, and we're going to do it live. So I'm going to demo a couple different things. One, I'm going to take an image, I'm going to take an insecure image, push it to ECR, and we're going to see what happens and see it in real time. Then I will patch that image, push it up, and let's see the difference in results. And then I'm going to take that same workflow, and I'm actually going to implement that into a CI/CD pipeline. And we're going to watch the pipeline when we push an insecure image and see what happens, and then do the same workflow where we patch the image and then see what happens. And then after the demo, we'll go through some getting started documentation. First things first, we're going to start in the AWS console. So in the AWS console under services, I'm under the Elastic Container Registry service. At this time, I shouldn't have any container images running stored there. So we're going to go ahead and click Get Started, and we're going to create a new repository. So when we look at the Create Repository section here, you'll notice we have our namespace. So the namespace will always be your account number and region, and then followed by the repo name. So in this example, I'm going to name my repo ECR Demo, and I'm not going to worry about, it already exists. So let's delete that, and let's start over. And we're going to go back to Get Started. And here we have our repo. We're going to create it, ECR Demo. Now, I am not going to worry about tag immutability. This is simply to enable functionality that I can't overwrite tags when I push. We're gonna leave that disabled for now. But under image scan settings, you can see I can enable scan on push. So what's gonna happen is every time we push an image to this repository, it's going to automatically trigger a scan on the back end and then give me the results for that scan. So here's our repository, and we've enabled scan on push. So now what I want to do is I want to build an image, and I actually want to push that image to this repository. So we're going to go to my terminal here and look at the IDE. And my Docker image in this example, I have an upstream image. It's very common to pull from an upstream image and then take that image and make it your own and harden it to fit your security requirements before you deploy to your environments. But in this example, I'm just taking an upstream image that I know has some vulnerabilities, and I'm going to build it locally, and then I'm actually going to push it to my repository, and we're going to see the results of the scan. So here I'm going to start with actually setting an environment variable for image file. So the name of my Docker file is dockerfile.insecure, and then I'm going to tag the image. So earlier when I was showing the demo, or when I was showing the slides, we had shown the latest tag. It's generally a better practice to not use latest as your tag when you're deploying to environments, and to use some sort of versioning for your tag. So in this example, I'm using the git hash, and I'm taking just the first 7 characters of that git hash for my tag. Another common practice is to use semantic versioning. Just depends on the organization and how your workflow is. But in the case of this demo, I'm going to use the git SHA as my tag. So I've set these as environment variables because I'm going to use them to build my Docker image. And then next, what's really nice about the AWS command line utility for ECR is because we're using Docker, we're building a Docker image and we're pushing a Docker image, you have to log into a repository in order to push that image, if it's a private repository like our ECR repositories are in this example. So we have a command line utility that will actually give us the login information we need to log into Docker. So I run AWS ECR get login, and that's going to give me this big long Docker command that will help me log into my repository. So let's clear that up. And next, now that we've logged into Docker, now we can push this image to Docker. And while this is going here, I'm going to go back to ECR. I want to grab the URI. So this is going to be, again, this is my namespace with my repository name. And what we're going to do is I'm going to set repo URL as this. So this is my repository URL. And now we're going to build the image. So I set these environment variables. We're going to run a Docker build. We're going to use the repo URL namespace with the tag of the git SHA. And then I'm saying the file is going to be this Docker file, which pulls from my insecure upstream image. And then we're going to build that Docker file here, that Docker image here. So what we've done is we've built the image. Now I want to take that image and I'm going to push it to ECR. So what we're going to do is Docker push repo URL git SHA. And now this is going to take my image. It's about 200 megs, and it's going to push this to ECR. And once this is done pushing, we're going to go to the ECR console, and we're going to look at that image and see what happens in real time. So I'm back in the console. I'm going to drill down into my repository name. And as you can see pretty quickly, my image is here. Okay, I have my tag, which was my git SHA, when it was pushed, the size. And as you can see, the scan is complete, and we have 7 vulnerabilities that are deemed high. So we drill down and we can see, we can sort by severity, and I can see I have 7 high vulnerabilities on this container image. And I can click and I can actually go to the upstream source and read more details about the vulnerability to determine if this is something that we actually see as needing to be patched, which most likely you would. So this is from the console. Let's go back to the command line. And what I want to do is I'm actually going to run a command to get the image findings in the command line here. So let's pull this up. And so what I have is the AWS CLI ECR describe image scan findings. I'm naming my repository and my tag. And now I'm just going to get the results. I'm going to pipe it to JQ to make it pretty. And we can see here's the scan findings. So just like what you saw in the console, it's the same content. I'm just able to access it programmatically. So again, we have the name of our CVE, the description, as well as the URI, severity level, and then the package name and version. So there's a lot of details here, and we can take action off of this data. Lastly, what I wanted to point out in the findings here is we have, you can just get like I mentioned earlier, a list of the severity counts per score. So I can see I have 7 high, 3 low, and 8 medium. Okay, so now what we've done is we've created a repository in ECR. We pushed an image that we've now deemed vulnerable and insecure, and we want to patch this image and push it up again. So let's go through the same process, except this time what I'm going to do is, if you remember earlier, so if I echo image URL, image file, you can see I was pointing to dockerfile.insecure. So I have the same image upstream, but all I did on that image was run a yum update. So if you're not familiar with yum, it's just a package manager. And basically what I'm doing is I'm instructing through the Docker file, I'm instructing to run a yum update on this image and to patch any old versions of software. Now, I've already done that, and for the sake of the demo and speed, I'm not going to do that here because I did it in the upstream image already. So I'm going to set image file to dockerfile.secure. Okay, and we're going to run that same Docker build process, except with the new image, with the new Docker file. And now we're going to simply push this up. So now what we've done is we've built a new image that's patched. Okay, so we've patched all those vulnerable packages, and now we're going to push that up to the container registry. So again, it's about 200 megabytes. We wait for that upload to happen, that push to ECR. And let's go back. We're going to refresh the page. And so as you can see, I overwrote the tag. I used the same tag because my git SHA didn't change. But now look at the difference. So we have our previous image, which had 7 high vulnerabilities. And we're able to, by simply running a yum update, we were able to update the packages on the operating system. And now we have no vulnerabilities. So looking at this, I feel pretty confident that I can promote this image to my deployment environments, and we're good to go. So this is how to do things, I would say, more manually. Let's look at this now from an automated perspective and bring a pipeline into the mix. So I have a code pipeline that looks at our version control. It looks at Git, which we're using AWS code commit. And when I merge code to code commit, it's going to trigger a build. And then if the build succeeds and passes the security vulnerability test, then it will be deployed to our environments. So going back here, so when we talk about code pipeline, one step I want to just mention really quick is in the build step here, we actually use what's called AWS code build. And code build is the service to build or deploy or however you want to run your deployments and builds. You can do them through code build for your automation and for your pipelines. So the way you define your instructions on how to build your particular code in your repository is use what's called the buildspec.yaml. So what you'll see here is code that's very similar to what I did locally from the command line. The difference is I've just automated it in a way where it doesn't need any human interaction. It can just do this, everything I did automatically on its own. So the same process, I'm logging in, except the difference is I'm just doing an eval on that get login command, which is that helper function, which will give me the Docker login command. This will automatically log me into ECR as my Docker repository. It's going to try to create the repository. If it doesn't exist, that's okay. I mean, if it exists, that's okay. It's just going to move on to the next step because we have that OR operator. And then we set the repo URL, we build the image and push it. The one piece here that's different is when I check the scans in the console or from the command line, I was doing it myself. So it was manually me doing it. But I actually wrote a script that I added to my post-build step called checkscans.sh, which will describe the image findings, and it's going to search for any scan findings that are high or critical. And if the scan findings are high or critical, we're going to return an error telling us there are critical high vulnerabilities. We're going to stop the build, we're going to stop the deployment, and this needs review. And from here, I could have added a step to notify someone or notify a team or trigger an alert to a monitoring system. But for the sake of the demo, I'm simply just going to have this very verbose and loud error message. Okay, so we're going to go back and we're going to go to the build spec now. And I'm going to change my image file to be the insecure image. So remember, this is the insecure image we pushed earlier. And now we'll notice that in Git, I have a change. So I'm going to add, I'm going to commit that I'm pushing an insecure image. And now I'm going to push. Full disclosure, yes, I'm pushing to master. This is for a demo. Obviously, it's recommended that if you're, you have your own workflow for what you deem appropriate to merge and what that, process looks like. I didn't have any peer review. It's just me right now. But generally, there's a peer review step before that code gets merged. So let's go to our code pipeline. And you can see from my merge, what's happened is we've triggered a build, and it pulled the latest source. So you can see here is my commit message. So we know this is my latest code. And what's going to happen is now code build is going to run these steps that I've defined here in my build spec, and it's going to build the image and push it to ECR. And then it's going to wait for those scan results. And depending on what those results are, it's either going to proceed or it's going to stop and tell me I need to patch my image because there's vulnerabilities. So I can drill down. Let's look at the logs and see what's going on in real time. This will take just a moment. And while we wait for that to provision, we can see also in the ECR repository, I now have a new image that was pushed. And almost, it's not pushed yet, but here it's going. So it's built the image, it's pulled from my upstream insecure image, and as you can see, it failed. So looking at the error message, it says there are critical high vulnerabilities, stopping build. So now going back to ECR, if we refresh, we should see that, yep, there's the image, it has those vulnerabilities. And you can take a look here. So here's the vulnerabilities, everything that we saw earlier when I was demoing from the command line. So what we've done here is we have successfully built an image, integrated security into our pipeline to catch that image being insecure and stopping it from being deployed to our environments. And we've ultimately protected ourselves from having vulnerable images running. Now, let's go back. And we're going to change the image, and now we're going to patch it. So we've been notified, we noticed our build failed. And now I want to fix it. So now I've patched the image, ready to go. And now I'm going to push. And so all I did is in my build spec, I'm just pointing to my secure image. Okay, so it's the same image. We just are running a yum update, which is we're updating the packages via the package manager. And now what we should see is our build's gonna run. It's gonna build the image, it's gonna push it to ECR, and it's gonna check the scans. And then it's gonna see that there's no vulnerabilities, and it'll simply spit out the results of the scan. So if there was anything informational or anything I want that maybe I'd want to review at a later time, I could absolutely do that. But it's not going to exit as a failure because there's no critical or high vulnerabilities. So going back to the code pipeline, we can see that we have officially sourced the code with the patched image that we're sourcing now, and we'll watch the workflow as it goes through. Again, it takes a minute to start up. It's basically provisioning the build environment. And what it's gonna do is run that same logic that we talked about earlier. And we can actually, while we wait for that, we can go back to our repository here and just look at our tags and see we've just updated images. So this is the new image that should be pushed here momentarily. Okay, so it's running through our build steps. It logged into Docker via Docker to our container registry repository, and it built the image, it pushed the image, it waited for the scan to complete, and then based on the findings, we've determined there are no vulnerabilities in this image anymore. So here's the scan results, but it's ready to go. Let's move forward. So now going back, you can see my pipeline, which was stopped earlier, has now successfully entered the deployment phase. So that's pretty much it. Basically what we've showcased is how to create a repository in ECR, how to push an image, how to enable scanning on push of that image, and then how to integrate ECR into a CI/CD pipeline. And what we've done is we've taken a DevSecOps approach to our automation, ensuring that not only are we iterating fast and building and deploying fast, but we're also secure while we're doing that as well. So that's it for the demo. And let's go back to our slides. So the last slide here is just with getting started on ECR. So there's a couple of links here to get started. First, there's an ECR overview. There's a getting started page. I highly recommend going to the getting started page. There's about a 5-minute video there from another developer advocate, Brent Langston, that just walks you through how to set up a repository in ECR and goes through lifecycle policies and some of the other features in ECR. So that's it. I want to thank everybody for taking the time today. And now I'm going to open it up for any questions.